There are planets that surprise astronomers, planets that challenge models, and then there are planets that appear almost magical in their beauty and mystery. One of the most striking examples is GJ 504b, a world that captured global attention not only because of its unusual characteristics, but also because of its color. This planet is often described as a bubblegum pink world, a giant gas planet glowing with a soft, rose-tinted hue that seems more like a fantasy illustration than a real world drifting through space. To understand why GJ 504b stands out so dramatically, we need to explore the system it belongs to. The planet orbits a star called GJ 504, also known as 59 Virginis. It is slightly hotter than our Sun and visible with small backyard telescopes. What makes this system fascinating is not the star itself, but the enormous distance at which this mysterious planet orbits. GJ 504b orbits its star at nearly 9 times the distance between Earth and the Sun, a region where massive planets rarely form. Planetary formation theories tell us that giant planets like Jupiter usually gather their mass close to the star within a dense disk of gas and dust. Farther out, the disk becomes thinner and colder, making it extremely difficult to gather enough material to form a giant world. Yet GJ 504b exists exactly in this unlikely region, a massive world, orbiting where models predict giant planets should struggle to form. This immediately raised questions. How did such a large planet develop at such an extreme distance? What mechanisms allowed it to grow? Let us look at what we know. GJ 504b is about 4 times the mass of Jupiter. It is a young planet, estimated to be around 160 million years old, which is extremely young when compared to Earth's age of over 4 billion years. Because it is so young, it radiates leftover heat from its formation, giving it a distinctive pink glow. This unusual color is not a stylistic exaggeration. It is based on actual infrared observations. Astronomers using the Subaru telescope in Hawaii detected this warm, rosy appearance, making GJ 504b visually unlike most gas giants we know. The color alone makes the planet extraordinary, but the true scientific puzzle lies in its location. According to the core accretion model, dust particles gather slowly, forming a rocky core which then attracts gas. But at such a large distance from the star, the disk would not normally have enough material for such rapid growth. This leaves astronomers with 2 possibilities. Either planetary disks are far more flexible and productive than we assumed, or GJ 504b formed in a different place and later migrated outward. Migration usually works the opposite way. Planets form far out and then migrate inward due to gravitational interactions with the disk. Outward migration is significantly more complex and requires specific conditions. Yet this may be exactly what happened here. Another theory is the gravitational instability model. The same alternative mechanism considered for other unusual planets. In this scenario, instead of slow growth, the disk becomes unstable and collapses rapidly, forming a giant planet in a single dramatic event. If GJ 504b truly formed this way, it would support the idea that multiple formation pathways exist across the galaxy, each leaving behind different types of worlds. GJ 504b is more than a scientific puzzle. It is a window into planetary evolution. Its pink glow tells us that planets begin their lives bright, warm, and dynamic. Its distance tells us that planets are far more diverse in their behavior than we expected. Its mass and youth tell us that giant planets can appear in locations that seem almost impossible. Every unusual world forces science to stretch its boundaries. GJ 504b is one of those worlds. The discovery of this pink gas giant reminds us that the universe is vast, creative, and full of surprises waiting to be uncovered. Some planets challenge our models. Some challenge our imagination. GJ 504b somehow manages to do both.